Hi friends, today I'm going to discuss on a topic of penicillin, and I would like to explain you the structure of penicillin. I will show you the structure using the molecular docking kit and what is the stereochemistry and what is the mechanism of action and what is the mechanism of action which is involved in during the resistance. Like sometimes when people are resistant to penicillin, that is, what is the mechanism actually involved in this. So firstly I'll go to the basic structure of penicillin. So I'm going to explain you the main important structures which are present in the penicillin. Penicillin comes under the category of beta-lactam antibiotics. And okay, before going into the penicillin structure, I would like to tell you the role which is involved in the patients, how this penicillin is acting on in treating the infections. Penicillin is an antibiotic which is a beta-lactam antibiotic used in the treatment of bacterial infections, gram-positive and gram-negative bacteria. So how does it act on the bacteria? It acts on the enzyme called transpeptidase. Transpeptidase is an enzyme which is involved in the formation of cell wall in the bacteria. So that cell wall biosynthesis can be hampered if you can use the beta-lactam antibiotics like penicillin or cephalosporins or ampicillin, amoxicillin, all these beta-lactam antibiotics. So firstly, I'm going to show you the structure of the penicillin, in which the major part of this penicillin is this beta-lactam antibiotic. This 4-ring is there, right? So this 4-ring called as a beta-lactam ring, which contains nitrogen atom and along with 3 carbon atoms, out of which 1 carbon is attached with the oxygen atom, and this is fused with a thiazolidine ring. So this beta-lactam is having a fused with the thiazolidine ring. Thiazolidine ring contains 1 sulfur atom and along with the nitrogen atom. So these two are important, and before going into the other main parts in this penicillin structure, I'm going to tell you the numbers, how we can give the numbers to this penicillin. You can take the numbering from the sulfur or you can take the numbering from the nitrogen. It doesn't matter. It depends on different books which we refer. So I'm going to take the numbering from the sulfur, and if we take this numbering from sulfur, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is the numbering which I have made. So in this numbering, on the second position there are 2 methyl groups attached to the carbon atom, and to the third carbon atom there is a carboxylic acid group. This is one of the main important functional group, and this is involved in sometimes in modification of the drug, which can be used as a prodrug. So this has a free carboxylic acid group which can be used as a prodrug. On the 6th position there is an acyl amino side chain, and to this acyl amino side chain there is also a linkage which we can add on, which like some R functional group. That can be anything like amoxicillin or ampicillin, or it can be phenoxym, benzyl penicillin or methicillin. It depends on whatever the functional group which you have attached here. So that comes under the 6th. This is also one of the main important positions in the penicillin structure. In this penicillin structure, there are 3 chiral carbons. One is this at the 3rd position, where this chiral carbon is having attached with 3 or 4 different functional groups. So here the the carboxylic acid group is away from the plane, and the 6th position here, this is also 1 chiral carbon, and this 2, 3, 4, 5. Sorry, this is the 5th position, and this is the 6th position in which there is an acyl amino side chain which is towards the plane. So this is the penicillin structure. Now we know that the mechanism of action is through the binding of the transpeptidase enzyme. So sometimes we see the patients who are resistant to the penicillin drug. So the reason behind this resistance because there is an increase in the production of an enzyme called beta-lactamase, which is produced by the bacteria itself. So that beta-lactamase will cleave the penicillin beta-lactam ring, which makes it non-functional. So the beta-lactamase enzyme binds to the penicillin structure, and through hydrolysis this beta-lactam ring gets broken. Look at this. This 4-membered beta-lactam ring is there, right? It gets broken like this, and this is broken this way, and this, and it leads and it becomes as an acid, and it becomes as a penicilloic acid. Look at here. So once through hydrolysis, if this becomes penicilloic acid, it is easily excreted from the body. So in that way the penicillin gets degraded. So how do you, so I'll put this back on as I'll make it the original penicillin structure now. While I was taking this out, I should attach a hydrogen atom here. I forgot to mention it here. Okay, so this becomes penicilloic acid, and that would lead to the degradation. So in order to avoid this degradation, what if we attach some bulky structure here on this functional group at the 6th position to the acyl amino side chain? So this leads to the obstruction to the actual beta-lactam ring. So now I'm attaching a bulky substituted benzene group, which is having 2 methoxy positions, 2 methoxy groups. So this becomes methicillin. So we might have come across the word called methicillin. So methicillin is resistant to beta-lactamase, but still, because of this indiscriminate use of antibiotics in our market and because of overprescription of these drugs, still there are some bacteria which are even overcome the methicillin, and people are getting resistant to methicillin also. So in that case it is called as a methicillin resistant infections. So in this way we can actually improve the penicillin structure by decreasing the resistance. We can now add many various groups to this side chain, making it as a methicillin or amoxicillin or ampicillin, or it can be any other. And if you look at this structure actually of penicillin, this looks like a half-opened book. The beta-lactam ring attached with thiazolidine ring. It is not planar. It looks like a half-opened book. Okay, so this is about the penicillin structure and its mechanism of action. Please like the video if you really like the video, you like it, and share and subscribe to the channel. Thank you very much.